Hi everyone, what's up? In this video, I'm going to explain window functions, majorly the ranking functions, using interview questions and answers. This is the second part of a two-part video series, and in this part, I'm going to discuss percent rank, Ntile, and cumulative distribution. In the first part, I had discussed row number, rank function, and dense rank function using questions and answers. So do check out that as well. And lastly, if you're new to this channel, then press the subscribe button so that you don't miss out on any of my upcoming videos. So folks, this is part of an ongoing series in which I discuss all the important topics that come with SQL. I discuss all the interview questions majorly along with explaining some important topics. And if you are interested in PySpark coding, then I have a playlist for that as well. So both the playlist on PySpark and SQL are present in the I button as well as in the description. So check both of these playlists out, and if you have not liked the video yet, then please do so that it reaches more and more people. So here we are on the Databricks notebook. Now these are the set of functions that we are going to discuss in this video. These functions are particularly useful when you want to compute relative rankings or perform statistical analysis on your data. Now out of these three, the cumulative distribution function is actually an analytical function, but I thought of keeping it in this video because this is somewhat similar to percent rank, and when we will discuss on this particular function, you will get to know what I mean. Let me show you the data. So this is the same employee data that I've used in the previous video, and as you can see, we have employee ID, full name, job, department, business unit, and some other columns as well. So we're going to leverage these columns and try to understand each of these questions. Let's move on to the first, that is percent rank. So the first topic of this video is percent rank. What is percent rank? It returns the percentile ranking number which ranges from 0 to 1 for rows within a window or a partition. Below is the syntax for percent rank. So it's percent rank over partition by department or by salary. Now let's try to understand what percent rank is and how it works. So based on the above syntax, what if I arrange the rows in ascending order of a column? Let's say the column is salary, and what I want to say that basically in department, I'm arranging all the records in ascending order based on the salary. Now what will happen? So if percent rank comes up to be 0, then that means there are 0 rows before it, or it is the lowest among all others. If percent rank comes up to be 0.16, then it means 16% of rows are before it. And if percent rank is equal to 1, then it means 100% rows are before it, or it is the highest value among all. I hope you're understanding what I'm trying to say by this. And there is a formula for calculating percent rank. So it totally depends on the rank function's value. Formula is rank minus 1 divided by total rows minus 1, where rank is the rank of the rows in that window and total rows is the total number of rows in that window. So let me show you the calculation. Let's suppose we are in this window, that is finance, and the salary is 4,000 and it is supposed to be lowest among all. Then the rank of this particular salary is 1. So according to our formula, 1 minus 1 divided by, and let's say there are total rows equal to 7, then 1 minus 1 divided by 7 minus 1, so it will obviously give us 0. That's why the percent rank came as 0. Now what does this 0 mean? That there is no salary lower than this. And similarly, if there is a salary, let's say 10,000, which is the highest among all, and more than one employee also gets this salary, then based on the formula, its rank, suppose it is 6. So 6 minus 1 divided by 7 minus 1 gives us 5 divided by 6 equal to 0.83. Let me show you an example to make it much more clearer using data. So here I have written this query. I'm selecting employee ID, department, salary. And what I've done is first I've written the percent rank value, and what I'm doing a round off on the percent rank, because what percent rank does is it returns us in a decimal format, and I'm trying to round it off to 2 decimal point. Then as I said, percent rank depends on the rank function. So I've also included the rank function with it. And by the way, if you want to learn more on rank function, then I have a dedicated video based on it. You can check out the video that is mentioned in the I button, and it is also mentioned in the description. Let's come back to this topic. So along with the percent rank and the rank function, I have also included the percentage of the percent rank. So what I'm doing is, as you can see, up till this part, it is similar to one that is highlighted above. So this will return me the percent rank, and all I'm doing is multiplying it by 100 to get the percentage value out of it. So once I run this query, I get this result. Let's just consider the first window, that is the finance window. Now here the lowest salary is 4,000. As you can see, I have ordered the salary in ascending order. So my rank will obviously be 1. So based on our formula, 1 minus 1, and there are total 7 rows, divided by 7 minus 1 equal to 0. So we get percent rank 0. This means that there is no salary lower than 4,000. Similarly, let's see about this 6,000 salary. Now the rank for 6,000 is 3. So based on our formula, 3 minus 1 gives us 2, divided by 7 minus 1, which gives us 6. So 2 divided by 6 gives us 0.33. And as you can see, the percentage is 33. So this percentage and this percent rank means that 33% of rows are lower than this particular salary. Same goes for this. You can see 10,000. Now it is the highest. And if I, based on my calculation, the rank is 6. So 6 minus 1 and total number of rows was 7. Divided by 7 minus 1, basically 5 divided by 6, so 0.83. So this means 83% of rows before it are lower than it. Now there is a catch in the whole percent rank scenario. Whenever you get a value in either in the smaller, in the higher section, like here you can see 10,000 is higher and there are 2 values of 10,000. So you will never get 1 as percent rank, because whenever there is a repetition, you can see the rank also decreases. Even though we have 7 total records, but the last rank is 6. So we will never get a 1 here. So there is something to remember. If you get a single value at the end of your particular ordering column, then it will always be 1. Let me show you that example. So let's say you have this sales window. Here you can see out of all the records of salary, 7,000 is the highest one, and there is only one occurrence of 7,000. So based on our calculation, the rank of 7,000 is 5. 5 minus 1 gives us 4, and I think there are total 5 records. So 5 minus 1 again 4. 4 divided by 4 is 1. Therefore you get 1 here. So this is something to remember. If the first record is there, then irrespective of how many times it occurs, the percent rank will always be 0%. And the last record, that is this one, if there is only single occurrence, then only it will be 1. Otherwise there will be some decimal pointer to it. Now I explained you how the percent rank works when you arrange the column in ascending order. Let me also show you how it will work when you arrange it in descending order. So here I've written this query. As you can see, I've selected employee ID, department, salary, and I've copied the above entire query actually. And what difference I've done is I'm ordering the salary column in descending order this time. As you can see, all the 3 functions have descending order. Now let's see the data. So once I run this, the highest salary in finance department or finance window is 10,000, right? So 10,000's rank is 1. Now 1 minus 1 divided by, again, 7 minus 1, it will give you 0. Now this time the 0% or 0% rank means there are 0% of rows which are higher than 10,000. Remember when we were doing an ascending order, I said that 0% of rows are there which are lower than 4,000. But when we are doing descending, the meaning becomes a little opposite. Here the meaning is 0% of rows or 0% of salary rows are higher than 10,000. Similarly, if I look at the last particular value, so the 7th record in finance department is 4,000, right? So here I get the percent rank or the percentage of rank equal to 83. This means 83% of records or 83% of employees have higher salary than this particular employee. I hope you're understanding what I'm trying to say here, and I hope you're understanding how percent rank works and what is the actual meaning of percent rank. So let's solve a question that will make things more clearer. So coming to the question, from employee data, what is the percentage of employees that are younger than other employees in research and development business unit? Okay, so what is the meaning of this question? Let's read. In R&D unit, if we rank the employees based on their ages, where the youngest gets rank 1 and oldest gets rank n, where n is equal to total number of employees. Then for employee X, if I want to know the percentage of employees younger than him, then I need to get the percent rank. So I think you understood what percent rank is used for. Let's see the solution. So I've selected employee ID, full name, business unit and age. And as you can see, the question defines that in research and development business unit. So basically we first have to find out for what percentage of employees are younger than other employees in all the business unit. Then we will filter out the research and development business unit out of the entire data. So here you can see I've written the percent rank syntax. It is percent rank over partition by business unit, order by age, and because we are looking into youngest records, so I've included ascending order only. And I'm also rounding it off to 2 decimal places and multiplying it by 100 to get the percentage. Finally, I'm filtering out R&D business unit here, and here you can see I've run this query. So this is the data we get. So here what it means, the age 24, percent rank of this age 24 is 0. Basically 0% of employees are younger than this person. Then for this particular person, 17% of employees are younger than this particular person. Similarly, for the third record, 33% of employees are younger than this particular person. So I hope you understand now how percent rank works, and if a question comes like this, what you have to do to solve it. Now let's go to the next topic. So the next section of this video is Cumdist. Cumdist calculates the cumulative distribution of an item from 0 to 1 within a window of items. A cumulative distribution shows the percentage of data points that are less than or equal to given value in a dataset. It is also called cumulative probability. So here is the formula of calculating Cumdist. Number of rows with a value which is less than equal to the current row's value, and that number is divided by total rows in a window. So before we see the working of Cumdist, let's try to understand how you calculate the cumulative distribution value. So let's look at this question to understand this. In the list of salaries, and here is the list, what is the cumulative distribution of each salary? So we have some steps to calculate this. First, count the number of salaries. So there are some 7 salaries. Then sort the salaries list. The list sorted in ascending order looks something like this. Then calculate cumulative distribution. So how to do that? For each unique salary, count how many salaries are less than or equal to that salary. Then divide this number by the total number of salaries, which is 7 in this case. Let's take up an example. So we have this salary equal to 4,000, and first we have to check the number of salaries which are less than equal to 4,000. And in the list I can see there are 2 salaries. So what we will do, we will divide 2 by total number of salaries, which is 7. 2 by 7, we get 0.286, or it is 28.6%. And so what does this mean? The cumulative distribution or cumulative probability of 4,000 is 28.6%. Similarly, if we take up another example, let's say 6,000. So we check the number of salaries that are less than 6,000. And if we look at the list, there are some 4 salaries which are less than or equal to 6,000. So 4 divided by 7, we get 0.57, and percentage is 57.1%. Similarly, if we check out the 8,000 salary, so there are some 5 rows or 5 values which are less than or equal to 8,000. So 5 divided by 7, we get 0.714. Finally, the last value, that is 10,000. So all the records in the list are less than or equal to, like they fall under this category where it is less than or equal to 10,000. So 7 divided by 7, we get 1. So one thing to notice here is when you calculate Cumdist, then the row that is the highest in the list, when you order it, that will always have Cumdist value equal to 1. Now let's check out this example in a query form. So as you can see, I ran this query. This query includes Cumdist first, and then I also calculated the percentage of that Cumdist. So this is the syntax of writing Cumdist. So first I write Cumdist over partition by department, order by salary, and I'm doing a ascending order. And here I'm doing a round off of 3. And in the below, what I'm doing a round off of 2 and also multiplying 100 to it to get the percentage. So just look at the finance data. Now here we have 4,000. So if you notice, the example I gave you is similar to the salary structure we have in the finance department. And as we discussed, so there is 28.5% of cumulative distribution value, which is for salary 4,000. Similarly, 10,000 is the last one. So it has 100% cumulative distribution. So I hope you understand how you calculate cumulative distribution and how does it look in the SQL query as well. Now let's check out some question. So the first question is, list all the employees whose age distribution in IT is more than 30%. So basically we have to find out the cumulative distribution of age of each employee falling under IT that are less than 30%. So here is how you do that. I first take the full name, department, age, and then I'm calculating the cumulative distribution. The query is Cumdist over partition by department, order by age, and that too in ascending order. then I'm multiplying it by 100 to get the percentage value, and finally I'm rounding it off to 2 decimal place. So this gives me the age percent, and I've also filtered out the department, which is equal to IT as asked in the question, and here we have it. So the cumulative distribution or age distribution of this employee is 14%, then the age distribution of this employee is 28.5%, and so on. And if, as I said in the previous examples, so you can see the last particular record, the last record, basically this particular age. So for all three of them, the cumulative distribution is 100. So this is something you have to remember. Whenever the last record comes up in the the ordering of that particular column, the last record will always have a cumulative distribution of 100. Let's move on and check out the other question. So coming to question number 2, list down the employees whose salary constitute for first 40% distribution compared to all salaries across the organization. So if you look closely, this question is quite similar to the one before it. What we have to do is we have to find the cumulative distribution of salaries of each employee across all the organization and check out based on the percentage of those cumulative distribution which are less than 40%. So here is how you do it. I have written an inner query first. So what I've taken is I've taken the round of cum dist, and here I've not mentioned any partition because we're checking across the organization. So over order by salary, and that to an ascending order, and I'm multiplying 100 to it so that I can get the percentage value. Finally, I'm doing a round off to 2 decimal place. I'm naming this column as salary dist percent. Now from this inner query, I have selected full name, department, salary, and salary dist percent, and I've also added the filter that where this salary distribution percentage is less than 40, and I've also ordered it by. And here is the final result. So you can see we have full name, department, and salary, and we have the percentage of the salary distribution. Basically, the salary 3000 has 4% distribution, the salary 3500 has 8%, 4000 has 16%, 4500 has some 28% distribution, and 5000 has 36% distribution. Remember, this is not 1 because this is not the entire list. We have filtered it out. In the entire list, whatever will be the last value, that will always be 1, and this is why I'm stressing on it. So that's it for the cumulative distribution. So there's one more point I want to discuss. Let's check that out. So before moving to the next section, there's one point that I wanted to discuss, which is what is the difference between percent rank and cum dist. Percent rank is percentile of rank within a window, and cum dist is cumulative distribution of a value across a window. So we have discussed on both of them individually, but let's compare the data together. So in this query, what I've done is I've selected department, salary, then I've also kept rank, and what I'm doing is partition by department and order by salary in ascending order. Then for percent rank also, I'm doing the same thing, partition by department and order by salary in ascending order. Just I've done a round off to keep it to 2 decimal place. Same goes for cum dist value, that also I'm doing the same thing. So if I print the result out, so you can see, let's check out for the finance department for now. So this salary 4000 or the first record, rank is 1. So obviously the percent rank will be 0. Basically there is no salary lesser than 4000. So we have 0% here. Now if we look at cum dist, then we have 29%. That means the distribution of this salary across the window is 29%. Same goes for the next record. So 6000's rank is 3. So the percent rank becomes 33%. Basically 33% of records are lesser than 6000, while 57% is the total distribution of this particular salary based on the cumulative distribution. So you can check out this notebook and come to this part to understand properly in what is happening in each window and how percent rank and cum dist are compared. So that's all I wanted to discuss, and let's move on to the next section. So coming to the last section of this video, which is Ntile. Now what does Ntile do? Ntile groups together a set of data within a partition, forming buckets of almost equal size, and assigns a number to each bucket. It is similar to bucketing concept, in which data is grouped into multiple folders inside a partition. In SQL query, you can achieve this using this grouping using Ntile. So here is the syntax of Ntile. I'm doing Ntile of n, where n is the number of buckets, and over partition by department, order by salary. Let's try to understand using this example. So what I've done is I've selected employee ID, department, salary, and I've written the Ntile syntax here, which is Ntile of 3, basically 3 buckets, over partition by department, order by salary, and in ascending order. as Ntile bucket. Let's check out the data. So let's focus on the finance data for now. As you can see, all the records are distributed into multiple buckets, basically 3 buckets. So this is bucket number 1, and all these 3 records fall into this bucket. Then this is bucket number 2. All the 2 records fall into this bucket, and here is bucket number 3. And these last two records fall in bucket number 3. Let's check out some more examples. Here you can see these 3 records fall into the bucket number 1. These 2 records fall into bucket number 2, and finally these 2 records also fall into bucket number 3. So this is how you can see inside a single partition, data has been grouped into 3 buckets or any number of buckets that you define here in the syntax. So let me show you the comparison between this. So here in the second query, what I've done is I've selected employee ID, department, salary, and I've written 3 Ntile codes. One is Ntile bucket 1. Here what I've done is I've added no value inside Ntile. So by default, it takes bucket equal to 1. And the over partition by department and order by salary are same. The only difference is Ntile bucket 2 means there are 2 buckets here, and Ntile bucket 3 means divide the data in each partition into 3 buckets. Let's check out the data. So as you can see, all the records have fallen into bucket number 1 for this column, that is Ntile bucket 1. Then these data have been divided into 2 buckets for Ntile bucket 2. 4 records went to bucket number 1, 3 records went to bucket number 2. And similar thing happened with the Ntile bucket 3 as well. 3 records went to bucket number 3, 2 records went to bucket number 2, and final 2 records went to bucket number 3. So this is the working of Ntile. It is very easy, right? So let's check out some questions now. So coming to a question, from employee data, segregate all the employees with older, mid, and younger age compared to each other, where the oldest comes at the top and so on. So what we have to do, we have to basically group the data based on the ages of the employee into a older section, a mid section, and a younger section. So definitely we have to use Ntile to do so. Let's check that out. So in this query, what I've done, select employee ID, age. Then what I'm doing is, because we have 3 sections here, so I've written Ntile of 3 buckets over order by age and description. And I did not include a partition here because in our question, no partition has been mentioned. So we will take employees across the organization. So that's why I'm doing over order by age and in descending order. Basically the older ones comes at the top as it is written in the query. And I'm calling this column as age Ntile. So let's check out the data. So these are all the employees who are the oldest. So they fall under the older category, that is bucket number 1. Then there are mid-aged people who fall under the bucket number 2, and the younger most fall under this bucket. So now that we have our age Ntile defined, let's check out how we can name the columns like into older, mid, and young. So here you can see what I've done. Select full name, age. Then I've used a case statement. If age Ntile equal to 1, then call it older. If age Ntile equal to 2, then call it mid. Else it is younger. And I'm calling the column which will store these 3 values as age status. So finally, what I'm doing is I have this inner query from where I'm getting the age Ntile value, and age Ntile is the same thing which we did here. Finally, if you go to the final result, as you can see, all these employees fall under the older category. All these employees fall under mid category, and all these employees finally fall under younger category. So I hope you understand how Ntile is working and how I've used it to solve this question. And that's it I had to show for Ntile. So that's it for this video. If you found it useful, then please share it with your friends and like the video. In the coming few weeks, I have planned many such videos on PySpark and SQL interview questions. So stay tuned for them, and if you have not subscribed, then please press the subscribe button, and I'll see you next time.